Okay, so here we go, our second video on solving quadratic equations. So remember, our approach here in this series of videos is we're going to look at 3 different ways you can solve it. The one that's going to be the most familiar to us, because it's going to feel like other equations that we've done, is what we did in the first video. That's solving using square roots. But if you end up in a situation where there's not just simply an x squared, where there's other things going on, then solving with square roots doesn't work well. And so we're going to look at the next method. This method, for most people, they feel like it's a fairly easy method, provided they're comfortable with factoring, because our next method is to solve using factoring. And that's what we're going to talk about in this video. Um, Finally, the third video, we'll talk about a final method using the quadratic formula. That's a method that always works, but most people find it algebraically difficult to use. So this video and that third video, you really get a choice. If you're comfortable with factoring, then solving using factoring is a great method because it's easier than the quadratic formula. But if you're not comfortable with factoring, then you just need to hold on for one more video. And once we learn the quadratic formula, you can choose to do every problem with the quadratic formula if you want to. That will be an option that you'll have. Okay, but before we get there, let's talk about using factoring, because like I said, most people find this to be an easier method than the quadratic formula. So here are the learning objectives for this particular video. Like the last time, we're going to be able to solve equations. This time, though, we're going to solve equations using factoring. And just like the first video, we're only looking for real solutions. So we're not worrying about imaginary numbers yet. The other thing is knowing when the equation will have 2 solutions, 1 solution, or 0 solutions. So we talked a little bit about that in the first video, but because these equations will look differently, the way that we will know how many solutions it has will also be different. Okay, so with that said, let's go ahead and take a look at this particular method. This entire method is built off of something called the zero factor property. Now, that's not a property that you need to know for our class, so I'm not going to try to define it here, but I am going to introduce the idea of this property by asking a couple questions. So imagine, if you will, that I have the number 3, and I multiply 3 by some secret mystery number, and the answer turns out to be 0. Can you guess what my secret mystery number is? Or perhaps I have a number, a different mystery number. Okay, so let's make it 2 question marks. It's a different secret mystery number. Playing a different game, I multiply it by -5, and the answer turns out to be 0. Can you guess what that number is? Well, you might be thinking, wait a second, you said it was different. Don't they both have to be a 0? And if you're thinking that, you're absolutely correct. Because we know in the land of real numbers with multiplication, the only way you can multiply 2 numbers together and have 0 be the answer is if one of those things is equal to 0. And that's the zero factor property. The property that says one of these things must be 0. That's the only way you can get 0 as an answer. Okay, so this is a concept or a property of numbers that we're going to leverage in our solving quadratic equations. So let's take a look at the type of quadratic equation that we're going to use factoring with. These are going to be equations, generally speaking, when we have 2 scenarios. Now, remember, if you don't have these 2 situations, you can always do a little algebra and make these situations happen, okay? But this is what we're going to want when we're factoring. Number 1 is we're going to want the quadratic expression to be in standard form. And I know you might be thinking, wait a second, I thought we were talking about quadratic equations. We are talking about quadratic equations, but I'm talking about just on one side of the equal sign, okay? On the side of the equal sign where the x squared stuff is at, we want that thing to be in standard form. And on the other side of the equal sign, we want it to be equal to 0. So that quadratic expression that is in standard form needs to be equal to 0. Okay? So factoring works best when you have those two things to start with. Okay, maybe that's what I should say. Factoring works best when these both things are true right from the very, very beginning. The reason why it works best under that situation is because these two things are necessary when you're factoring, okay? So that's the way we're going to start every single problem. Therefore, start every problem by making the equation be in standard form and equal to 0. Standard form equal to 0. Okay? Now, every single time we're going to solve using factoring, we're going to make it in standard form equal to 0. Now, this is not what we did in the first video, right? That's not what we did when we were solving things using square roots. And so this is one of the things to look at. Do you have a scenario where you just have one thing that's being squared and that's it? Then don't mess around with all this business, just use square roots. But if you have other things going on, if you have x's and you have x squareds both, then what we're going to want to do is get it into standard form and equal to 0. Okay, so that's the final thing that we're going to look at. And let's look at an actual example and talk about some steps together as we talk about this third and final thing. Okay, and I'm going to, just for the sake of ease, I'm going to make this almost in standard form equal to 0 right from the beginning. Not quite. Okay, I want to be able to do a little bit of work, but not quite. Okay, so let's say I have x squared plus 5x, and that's equal to -6. Okay, so this is the first problem we're going to solve. Now, right away, I want to make sure we recognize why we cannot use square roots. If I take the square root of this x squared, then I'm going to end up with a square root of x right here because there's no square to cancel out the square root on this x. And so the problem is there's no way for me to get these things to combine together. There's no way to get an x by itself equal to a number. So is anytime I have an x that is squared and an x that is not squared, I can never use square roots in that type of a problem. I have to either use factoring or what we'll learn in the third video with the quadratic formula. I have to do it one or the other, okay? In this video, though, we're going to do factoring. So here are our steps. Well, I already told you what step number 1 is. Step number 1 is get it into standard form and equal to 0. So rearrange as we need to get standard form and equal to 0. Okay, now as far as standard form goes, in this problem, there's not much to do. I don't have to simplify anything. There's no like terms to combine. Standard form, no big deal. Equal to 0, well, there's only one thing I have to do and I'll be equal to 0. I simply need to add 6 to both sides of my equation. If I do that, then on this side, the 6's will cancel and I'll be equal to 0, which is what I want. On the other side, this 6 does not have an x or an x squared. So it's not like terms with any of these things. Remember, like terms, they have to have the same variable and they have to have the same exponent. None of these have the same variable and the same exponent both. So none of these are like terms. I can't combine them. I'm just going to simply write all of them down. Okay, so there's that part. So that's step 1. Get it in standard form and equal to 0. Step number 2 is factor the quadratic expression. So this goes back to what we did a few weeks ago. Just ignore the equal sign, treat it like it's an expression like we've done before, and factor that. Now, if you remember, the way that we learned to factor it in the previous video is that we would take the number in front of the x squared, which in this case is a sneaky ninja, and we would multiply that number times the constant at the end. So 1 times 6, that's equal to 6. And then we would find the factor pairs of that product. So the factor pairs of 6. And I would choose the one pair that does this sign, so adds, to equal this number, adds to be 5. Okay, so that was the method or the process we learned before. We said in this initial step where I'm picking my pair, I'm ignoring all the signs except for whether it's add or subtract. So I just treat everything like it's positive. I treat everything positive and I say, okay, I want it to add up to be 5. So that's these. If I treat them all like they're positive, 1 and 6 add up to be 7, so I cannot use that. 2 and 3 add up to be 5. That's the one I want to use. Now I take a second to look at the sign. I need them to add up to be a positive 5. So that means I need the 2 and the 3 to both be positive. If I had a negative 2 and a negative 3, I would get negative 5. Okay, and if I had other signs, I would get something else. So it has to be positive. So I've got an x squared plus 2x plus 3x plus 6. And then I can use grouping, is the method we learned. So in my first group, they both have x's in common. And if I factor out an x, then I'm going to end up with an x plus 2. And in the second group, I know it has to have an x plus 2. The parentheses need to match. So if I divide, I can deduce that I must have factored out a 3. And then I can always distribute to check that. So that means one of my factors is an x plus 2, and the other factor is an x plus 3. Okay, so that's my factoring step. Okay, so we've got that done. And of course, if you need a reminder on factoring steps, if you're a little bit rusty with that, you can always go back and watch those videos from earlier in our class or review those notes from earlier in our class. Okay, so there's step 2. Step 2 is done. Step 2, I will say, is the longest and most complicated step of this process. Then we move on to step 3. And this is where we use that thing called the zero factor property, right? So that property told us if you have two things being multiplied together, which I do, I have this thing right here. I don't know exactly what that thing is. I just know that there's a plus 2 in it, but I don't know, is it like negative 5 plus 2? Is it 12 plus 2? I don't know. So I don't know exactly what this thing is. And I don't know exactly what this thing is. I know it's different because this one has a plus 3, but again, I don't know, is it 10 plus 3? Is it negative 69 plus 3? I don't know, it's something. I just don't know, okay? So I've got two things being multiplied and they equal 0. So while I do not know what either one of them is, I know that one of them has to be a 0. At least one of them has to be a 0. And so this is the way that we finish. To find our possible answers, I'm going to set each one equal to 0. And then I'll solve those little equations. Okay, so what that's going to do right now is it's going to give me two equations to solve. One equation when x plus 2 is equal to 0, and another equation when x plus 3 is equal to 0. And so I'm going to solve those two equations. This is not particularly difficult algebra to do. Most of us would feel fairly comfortable with these. And so there are my two answers. Now, I've got two answers. I don't know for sure which is the final right answer, so I write both of them down. So I'm going to say for this particular problem, my solutions are x equals -2 or x equals -3. Those are my solutions. And that would be it for this problem. Of course, I can always check both of these answers by plugging them back in to make sure that they work and that I do actually get -6 for the answer. Okay, so this is our basic idea. Rearrange to get standard form equal to 0, and then factor, and then set each factor equal to 0 and solve them individually. Okay, so That takes care of our first learning objective. Remember, our first learning objective was just simply to be able to solve. And this is exactly the way we'll do it. This is our procedure. Like we do usually, I will have a second video where I just go through multiple examples. So if this one example is not enough, you can watch that other video to get more examples. But in all of those examples, these are the steps that we'll use. Okay, so that's not ever going to change. Okay, so that brings us then to our second learning objective. The second learning objective was to know when I'm going to have two solutions, one solution, or zero solution. Okay, well, from this problem, it might seem like we should always get two solutions, right? Because when we factor this, we're going to have this thing and this thing, boom. It seems like we should always get two solutions, right? But there is a scenario where we would only get one solution. And so let's take a look at an example that causes us to get only one solution. So suppose I have a 4x squared minus 12x plus 9 equal to 0. So for this, I'm going to just already start off in standard form, already equal to 0. We're just going to start like that so that we can focus on what would cause me to get only one solution. Okay, so here are our steps. What I'm going to ask you to do is pause the video right here and try and do just step 1 and step 2. Just try and get it factored. And then once you've got it factored, push play on the video and we can talk about this. All right, so hopefully you've factored this already. There are two ways that you could factor this. You could multiply 4 times 9, you would get 36, and then find all the factors of 36 to figure out which ones work in this particular problem. Okay, so the ones that I need to pick are the ones that add up to equal 12. So it would be 6 and 6. And then you could just go from there. It needs to be a negative 12. So I'd use a negative 6 and a negative 6. And you could do it that way and that would be fine. If you did that, that's good. But there's a different way that you could do this. Remember, we talked about recognizing when these two things are squares, that we have a shortcut. I can take the square root of both of those things. So the square root of 4x would be a 2x. The square root of 9 would be a 3. And then I just keep this sign in the middle. And that squared is equal to the factorization. Okay, so that would be the shortcut. Again, for the long way, we would get the exact same answer. We said we would use a negative 6 and a negative 6. And if I find the greatest common factor here, I'm going to get a 2x. And then for this, I know it has to be a 2x minus 3. So I must have factored out a negative 3. And so notice I get 2x minus 3 times itself. And of course, anything times itself is like having that thing squared. So it does work out that whether I do it the long way or the shortcut, they both give me the same answer. Okay, but now think about what happens when I get to step 3. Set each factor equal to 0 and solve. So if you do it with a shortcut, you need to recognize I have two factors here, but they're identical, right? This square means that I have this thing times itself. That's what that means, right? So I do have two factors, they're just identical. And notice what happens if I set these both equal to 0, because of the fact that they're identical, I'm going to get the same answer from both. Both of them are going to give me x equals 3/2 or 1.5, depending on how you like to write it. Okay, so they both are going to give me that exact same answer. So notice that because this was a perfect square trinomial, when I factored it, my factors were identical. And so, I mean, you might think of it as, yeah, we got two answers, but the two answers are the same. So what are the options? Well, the only option is 3/2. That's the only option. So this is a situation where we would only get one solution, excuse me. This is the situation where we'd only get one solution, where the factors end up to be the same because our trinomial was a perfect square to start with, okay? If our factors are different, we're going to get two solutions. If our factors are the same, we're going to get one solution, right? Now, here's the thing. If you can solve it with factoring, notice I say if, because unfortunately, not every problem can be solved with factoring. But if you can solve it by factoring, you'll never get a problem with no solutions, all right? So all the problems in our class, if you can factor it, you'll either get one solution if it's a perfect square, or you'll get two solutions if it's not a perfect square. But you'll never get zero solutions by factoring, all right? So there is the problems that we're looking at here today. Like I said, there's going to be a second video. If you need more examples, make sure that you watch that second video to get more examples. But this is our basic outline. There's our basic procedure. And these were our learning objectives. Know when we're going to get to 1 or 0 solutions and know how to solve. So thanks for watching. Have a good one.